everybody. Welcome back. Happy New Year. It's a brand new semester for our STEAM Saturday videos, and I'm so excited to be with you guys today to talk about and show you some experiments with surface tension. But before we can do that, we need to go over everything you're going to need to do this, because there are a lot of different things, but I guarantee you have all of them in your house, probably in your kitchen or very close to it. Okay, first thing is you're going to need some soap. We're getting the big stuff out of the way first. You're going to need some dish soap. So make sure you have that. You're going to need quite a bit of water. So I've got a pitcher full here. So you can grab bottles, whatever you want to. You're going to need some pepper. You're going to need some food coloring. The darker the better on this. I'm probably going to use blue, but you can use any dark color you want to. You're going to need some straight pins. Make sure you have a couple of them, because the experiment with the straight pin may not work the first time. You're going to need a couple of paper clips too. You're going to need a penny, and the newer it is the better, the shinier it is the better, because you're going to be able to see really well what's going on. You're going to need a couple of different sizes of glass containers. I've got a really small one for my penny experiment and a slightly bigger one for the straight pin and paperclip experiment. You're also going to need an eyedropper or a medicine dropper for the penny experiment. And then you're going to need a casserole dish or a pie plate for the last experiment we're going to do. And when you're doing your penny experiment, you're going to want either a couple of napkins or some paper plates, because guys, all of these experiments are going to be really, really wet. But the first thing we need to talk about before we can really do any of this stuff is what exactly surface tension is. What's happening when surface tension comes into the picture. And what surface tension is what happens when the surface of a liquid contracts to fill the smallest available area for that surface. So every time you pour yourself a glass of juice or a glass of milk or a glass of water, or you fill up your tub, you fill up a kiddie pool, you fill up a swimming pool, every time you put water in something, the top of that water is going to shrink to its smallest available area for the surface of that water. And if you guys remember from the STEAM Saturday we did last October with the fizzy lava lamps, we talked about the fact that water molecules are polar. The hydrogen atoms are slightly positive, the oxygen atom is slightly negative, so the molecule pulls towards each other, and so water molecules, water droplets, attract each other like magnets. So in a pitcher of water like this, all the water droplets down underneath here are attracted in all directions, but the water droplets here on the very top are only pulled inwards and sideways. They're not pulled downwards. They're not pulled on all their sides. They're only pulled in and sideways. So that is what we're going to be looking at with surface tension. And this video, you guys, is going to be a little different, because all of these experiments are going to have to be done from an overhead perspective. Okay, so a lot of what you're going to see is the experiment itself, my hand or hands, but you're going to still be able to hear me. So let's get this. All right, guys, so here we are set up for our first experiment. I've got my napkins here, 2 of them. I've got my penny, and I've got my water dropper, my eyedropper, and my little glass full of very blue water right here next to me. See, here it is. And I'm going to put a few drops of water in this eyedropper, and we're going to see just how many drops of liquid the top of this penny can hold. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Look at that, you guys. 14. Ooh. 15. Ooh, I'm going to have to refill. 16, 17, 18, 19. Ooh, look, you guys, look. 20, 21. Oh, 21. 21 drops of liquid on the head of a penny before the surface tension would break. That is pretty cool. That's how strong the surface tension of water is, you guys. 21 drops on a penny before the surface tension actually broke. How cool is that? All right, we're going to move this over to the side. I'm going to be very careful with this blue liquid. Okay. Now, we're going to get ready for this next experiment. This is my bigger glass with just some water in it, but you can see the top of the water. You can see the surface tension there. Now we have to see, will a paper clip float on the top of this water? And it might not. It might sink. But we're going to try a paper clip and a straight pin. And I'm going to try a couple of times to see. Nope, see, that went straight to the bottom. And it might be because it's too heavy. Let's see. We'll see. Nope, that one went to the bottom. So will this one, because this one's really heavy. Different sizes and materials of paper clips all went down to the bottom. But what's going to happen if I take my straight pin, and you can see this is the kind that has a head on it, and put it down in there. Nope, that one sunk. This may take a couple of tries, you guys. Look. Ha ha ha. There you have it, boys and girls. The straight pin is actually floating on the top of the water. The paper clip sunk, but the straight pin did not. There it is. It's actually floating. How cool is that? So awesome. Okay. For our next one, this is gonna, for our last experiment here, this is gonna take a little bit of work. This is my pie plate, my pie dish. And I'm going to really shake some pepper out here. And the pepper, hold on, show you while I'm talking. The pepper is actually hydrophobic. It doesn't like water, so it's gonna float on the top of it. I'm gonna shake. Okay, can you guys see all the pepper in that water? Kind of looks like dirt this close up. But I wonder what might happen if I put some dish soap on my hand and put it down in this pepper. We're gonna see here in just a minute. All right, now let me move this up a little bit so you guys can see. You can see all the pepper floating in there, and there is dish soap all over my hand. I want you guys to watch what's going to happen. See, look, the pepper runs away from my hand. It just did. It ran away from my hand. And the reason the pepper ran away from my hand is really cool. Soap actually broke the surface tension of the water, and because the water didn't want the surface tension to be broken, it carried the pepper with it. The water molecules didn't want me to break the surface tension with the soap, so the water carried the pepper with it. And now that the soap has actually broken the surface tension of the water, the pepper is going to sink down into the water and stay in there. So there you have it, guys. 3 different experiments going through just how awesome surface tension is. And so now I'm going to show you guys a couple of the resources we have here at the library if you're interested in more experiments with water and or surface tension. The first one is experiments with water. This is in our juvenile nonfiction section in 546.2. This goes through surface tension and a lot of other things that you can do with water, because water is totally awesome. This next one is first place science fair projects for inquisitive kids. This is in 507 in the juvenile nonfiction. This has surface tension experiments in it, but also a lot more if you're interested in that. And then we have Walter Wick's A Drop of Water. I love this book, you guys. This is in juvenile nonfiction in the 546s as well. This goes through surface tension and a lot of other cool stuff that water can do. And you guys, the experiments don't have to end here. You can actually test the surface tension of other liquids. You can test the surface tension of juice. You can test the surface tension of milk. You could test the surface tension of your soda and see if it's any different from regular water. But you should try it and see, because the surface tension of every liquid is different. So happy experimenting, you guys. Thanks so much for joining me today, and I'll see you guys next month for another awesome STEAM Saturday. Bye.